Hello, this is Sher Stambe, and today I will be discussing a problem which involves a tree kind of structure and a DFS search in tree. So the problem is, given an array of rocks in a lake, can the frog make it to the other end of the lake? We're required to find out if there's a path from one end of the lake to other end of the lake. The constraints are, the frog can only jump 2 or 5 blocks at a time. Frog can travel forward, or frog can also travel backwards. Okay, so here is an array that will be given to us. These are the rocks within that path. Wherever we see R is the position of the rock where the frog can actually jump and land. We want to find out if the frog can make it from start to finish, and the frog can travel forward as well as the frog can travel backwards. Okay, so what we want to do is, first of all, we would like to find out if there's a position a frog can jump from the starting position to second and fifth. Given that index starts from 0, second position will be at the position 1. Jump of 2 units will be at the position 1, and the jump of 5 units will be at the position 4. So we have that position here. From there, we want to find out if there is a next jump that is possible for a frog to go 2 blocks more. So we have 1, 2. It's possible. Now, I want to write down the parents of the parent position from where the frog started the jump. That way we can track it. If we want to go backwards, we need to know where to go. So I want to say -1 as position of the start position. So from here, the frog can jump 2 units. So this position, so the parent of this position will be 1. From this position, frog can jump 2 units or 5 units. That is 1, 2. There is no rock here, so frog cannot jump here. From this position, frog can jump. We will test if the frog can go 5 blocks. So that's 1, 2, 3, 4, 5. That's possible. So the frog can get over this position in block 8, and its parent will be position 3. I'll mark it here. From this position, we'll find out if the frog can go 2 positions forward. 1, 2. No, there is no rock there, so the frog cannot land there. We'll find out if there is a position at 5 blocks from this position 8. 1, 2, 3, 5, 3, 4, 5. There is a rock there, which means the frog can come from here to here. And the parent position for this 13th block would be 8. From here, we'll find out if there is a position where the frog can go by jumping 2 blocks. 1, 2. Yep, that is possible. So the parent position of this will be 13. We'll find out if there is a position that frog can jump into from here at 2. 1, 2. No. Can the frog jump 5 units? Let's find out. 1, 2, 3, 4, 5. No. So the frog cannot go from here to finish. But this frog, can he go backwards and try another path? We'll try to find out. So for that, we need to go backwards. Position of this would be 8. Parent of this is 13th. So we'll go to 13th and remove the parent here. From 13th, we jumped 2 and we landed here. And then from there, we did not have any path. So we'll try to find out if we can jump 5 and then find out if there's a path from there. That is 1, 2, 3, 4, 5. Yes, there is a path. So its parent position will be 13th. From here, we'll find out if the frog can jump 2 units. 1, 2, no. We'll find out if the frog can jump 5 units. That is 1, 2, 3, 4, 5. No. So we'll go back and we'll see that the parent position of that is 13. So we'll come here. And over here, we've explored both paths. There's no more that we can go. There's no other path that we can explore and find out if there's a if the frog can finish this, or get to the other end of the lake. So parent is 0. We'll go to its parent position, 8. We did a jump of 5, and we saw that it's not possible to get to the finish the traverse and then get to the other end of the lake. Then the 2 is not possible, so at this position we can say that the frog cannot cross the lake. So this thing works only if at one position there's one path explored, but we can have from one position it might be possible to start 2 different paths. So what can be done is I want to explore at this position, from each position where the rock is available, I want to explore if there's a rock 2 blocks away from there, and if there's a rock 5 blocks away from there. From this position, I want to find out if there's a rock 2 blocks away from there, and there's a rock 5 blocks away from there. If there is, I can further explore the path. It seems like the binary tree kind of thing. At each position, we have 2 different children nodes. Is there a path from 2, or is there a path from 5? So that is what I try to do in that code. What we do here is we write a class with position and name it as position node. In that we write down the root position, which is the starting position, and then we add a payload of position block number, which is the position of the rock in that array. And then we find out if there are children nodes. So from this position block, we find out if there is a rock 2 nodes away or 2 blocks away, and if there is, we will add it in the list. We will also find out if there is a rock 5 blocks away, and if that is the case, then we'll add it in the list. We will also track for these things what is the parent node. For the root node, the parent node would be null, but if there is a rock 2 blocks away from this position block number, the parent node of that new block that we will create at 2, which is 2 blocks away, will be this block number. We'll see how that goes. I will create the root node, which is position block number -1, and then using that I will call a function does path exist, which passes root node, and then also the array of the rocks in the lake. For the sake of this creation over here, I've used a generator function which randomly generates array size and then randomly generates positions for the rock. Initially it fills in all the position as 0 for the rocks, but not for the rocks. All the positions are marked as 0. And if randomly I generate the next rock position, or the next rock integer, and then just add it in the list, and then just add it in the loop of iteration in the loop, and then mark it as a rock position. That's what I do over here. This will be supplied to you by the problem viewer. Once you have this problem, you call this function does path exist for that array and my root node. I pass a root node in that function. What we want to do is we want to say path exists is false, and then we pass in the current root node. We term it as current node, and then from that node we find out if there is a rock 2 blocks away from the current node, or if there is a block, or if there is a rock 5 blocks away from the current node. then we'll return true. This is our last condition. Before we get there, what we want to do is, if there's a rock 2 blocks away from current position, current node's position block number, we add 2, and we find out if there's a rock. We find out, is there a path from that position in this given array of rocks from this position node, which will be the next block. Similarly, if there is a rock on the block which is 5 blocks away from current node, then I want to call the function again, and I'll say, is there a path in this given array of rocks from this position? Explore that path. This condition checks if the current node plus 2 is greater than or equal to actual length of the array, which means if this is the finish line, and if I land over here, if there was a rock here, and if I land over here, then from this position I can always finish. It's greater than plus 2. Similarly, if there is a rock here, and if I jump a jump of 2 units, I'll always finish this line. If there's a rock here, I cannot jump 2 units of jump and then finish this, but I can jump 5 units of jump and then finish this. So it's also a finish. That's why we check if from current position block number I can jump 2 units and get to the finish line, or from current block position I can jump 5 units and get to the finish line. Actually, that just checks if the array is lesser than or equal to plus 5. But this does look like a tree that we learn, a binary tree that we learn. I think if we want to extend this and we have a jump of like 3 as well, we could add, if there's a jump of 3, which can actually solve the problem, which can add in the condition here. So let's see if that works. Sometimes it produces the result true, and sometimes it's false. Or it's true, true, false. Cool. I've attempted 800 times. All of them are complete. This code is available on LeetCode in my playground over here. I will add the link in the YouTube video, and you can access this here if you want to. I hope this helps somebody. Thank you.